So do you remember what 2 to the power 0 is equal to? 1. Why is that? Because it's a rule? It just said it was. It just makes no sense. Like, they take the average. What's the average between 0 and 2? It's 1, so that must be why it is. It's a law. Yeah, if you have 0 2's, you have one of them. What? So, is it, are you okay with it? You're just okay with it? Just let it be? It's just a rule? Is there an option for why? Yeah, there is a reason. It has to be 1. Okay, now I'm gonna try to come up with 2 different reasons why it has to be 1 and see if you guys, agree with that or not. First one is using your quotient rule. Here's your quotient rule. If I have 3 to the 8 over 3 to the 6, what do? Same base. Subtract, so you get 3 squared, which is? 9. Good job. 9. Now, if I had 3 to the 8 over 3 to the 8, those would be the same numbers. So the same number divided by the same number is always 1. Okay? If you have 100 divided by 100, that's 1. 3 to the 8 divided by 3 to the 8, whew, that's a big number. What would be that? 64, 65, 61 or something like that? That's what I'm guessing. Anyways. What would happen if you subtract the exponents? You would get 3 to the 0. So maybe that is one of the reasons why it is. No, I'm sure. But that... Hey, I got it right. I got 3 to the 8 right. Nice. And yeah, I've got a little few more numbers to go. Okay, now another thing we could look at is mathematics is based on patterns. So 3 to the 1 is equal to 3. That makes sense by definition. 3 squared is equal to 9, and 3 cubed is equal to 27. If I kept this pattern going on the left, what number would I put above 3 cubed? If I'm going to keep the pattern going, I'm going to write here 3 to the 4. And if I'm going to keep the pattern going on the right, what's the pattern that's happening from here to here to here to here? Times by 3. So if I take 27 and multiply it by 3, I get 81. Now, that's moving up. Who says we can't keep the pattern going but go the opposite direction? If I'm going the opposite direction, what would happen next on the left? 3 to the 0. And if you're going the opposite direction this way, you'd be divide by 3. Okay? So then you would get 1. Now the cool thing about this pattern is it keeps working. What comes after 3 to the 0? 3 to the negative 1. Did you guys do negative exponents last year? A little bit. What is 3 to the negative 1? Well, if you take 1 and divide it by 3, you get 1 divided by 3. And if you keep going and do 3 to the negative 2, dividing by 3 again would give you 1 over 3 squared, which is 1 over 9. So what is? So we're going to learn about negative exponents today, and the pattern that we see here could keep going. So if you wanted to figure out in your head what 4 to the negative 3 is, you would say to yourself, well, that's the same as 1 over 4 to the 3, because I would have to keep dividing by 4. And you could simplify that to 1 over 64. Yes? They're both right. They're both good explanations. The one explanation really explained why, something to the 0 is 1, because if you have the same number on the top and the bottom, that works out. This one also explains the negative exponent rule with the quotient rule, because you might have learned last year how to simplify this. And your teacher might have said, where are there more 7s, on the top or the bottom? On the bottom. How many more? 2. So this is going to end up, once everything cancels out, you'll be left with 2 7s on the bottom, which is 1 over 49. But if I use my exponent law of subtracting, what do I get? 5 minus 7, I get 7 to the negative 2. So we learned that if you have a negative exponent, you just move it to the other part of the fraction. Yeah.
Why is it that like 3 to the 1 is 3, and then 3 times 3 is 9, but 3 to the 0 is 1, but 1 times 3 is not 1?
Okay. 3 times 3 is 9, right? That's how I get from here to here. 3 to the 0 is 1, but 1 times 3 gets you up to this one. 1 times 3. Oh, that's good. You were thinking 1 cubed. Not a problem. Okay, so this, anything to the 0 is 1, mostly. There is one number to the 0 that is not equal to 1. Is it 0 to the 0? Well, try it on your calculator. What happens when you plug in 0 to the 0 to your calculator? You get an error. All right? It's not real. It's scary. It's Halloween. Boo. Boo. Okay? Now, why is it an error? Because doesn't it fit a pattern? Shouldn't it be? Shouldn't it be 1? But or should it be 0? See, one pattern says it should be 0. Another pattern says it should be 1. And when we run into these problems in mathematics where a number should be 2 things, we just end up saying not defined or error. Because you'd hate to make some people angry if you pick theirs over somebody else's.
Okay, so how, on your calculator, how do you add an exponent that's like greater than 2? How would you put it
You would use the little hat button. So you go 3, hat button, 5, and you'll get 243.
Okay, thank you.
Yep.
Oh, wait.
Yes.
Why do the grade 9s get an option? Like, if they were constant.
Yeah, why don't we get that?
Okay, so tomorrow we'll put another quiz.
No.
What are you talking about?
This is Catherine's idea.
No. I'm asking, why did we get that option?
Okay, some definitions. The grade 9s have a test or quiz every Friday. That's their schedule.
Really?
Yeah, every Friday. That's. I like Fridays. I like math tests.
Why does it add a quiz on a Friday?
Yeah, it's like having your Friday.
So, the reciprocal. Here's an example. The reciprocal of 3/19 is 19 over 3. And you've seen reciprocal before in like multiplying by the reciprocal when you're dividing. Whoa, that's not going to spell reciprocal.
Press the color.
There we go. The reciprocal of 3 to the negative 2 is 3 squared. Because 3 to the negative 2 is 1 over 9. And 3 squared is 9 over 1. It's just the flip.
Only the
I'll be going on the highway thinking about this. That's I'm gonna be like 20 years old, you know, like wow, that really came in handy. Wow, you know, I could go negative 30 miles per hour. I know it is.
Well,
I love that, yeah, that kind of drift off, you're drifting.
so here's your negative exponent rule,
Just trying to be more
right? And if you want to think of this when you do take physics and you're driving down the road thinking about math and don't realize there's a turn ahead and drive right off that cliff, right? And then you say, how do they write in IB physics, how do they write gravity? It's 9.8 meters per second squared, but it's written with a negative exponent. And you're like, that's where I could use it. Gravity. Boom.
Are you required to take like IB physics?
No, you're not required to take IB physics. So, I think you guys get me off topic more than the other class does. Okay, so let's do some more examples. What would 5/3 equal? This is equal to 1 over 9. 1 over 5 to the positive 3. 1 over 125. What would 1 over 4 to the negative 2 equal?
Oh, wait, that'd be 1 over a fraction.
That would be 4.
Right, and that what ends up happening is whenever there's a negative exponent in a denominator, it'll get flipped to the numerator. If it's in the numerator, like it is in these first two examples, it gets flipped down to the denominator. So 1 over 4 to the negative 2 becomes 4 to the 2. Over 1 if you'd like, which is just 16. Now, if you had multiple negative exponents, along with some things that weren't negative exponents, 2 squared, 3 to the negative 3 over 5 to the negative 6, 7 cubed.
Wait, so that'd be 2
to the 7 cubed, and then blind, and then it's 5 to the
2 to the negative 4, 3 to positive.
Okay, you gotta flip them.
So which ones are going to get moved? If you want to write them all with positive exponents, so you can actually understand this, the 2 squared isn't going to get moved. Neither will the 7 cubed, because those ones are already positive. The 5 to the 6 will be up there, and the 3 to the 3 will be down there. So the idea of a negative exponent, the main idea of the negative exponent is it just moves to the other part of the fraction and becomes a positive exponent. The positive numbers stay where they are, and you just switch the ones that have negative exponents. Okay? So we can now evaluate these without a calculator. And it practices some of your exponent rules, because your exponent rules for negative exponents are the same as your exponent rules for fractions, which are the same as your exponent rules for positive numbers. Okay. First of all, we'll get the answer for A up there. How did A go? 1 over 7 squared is step number 1. And evaluate means get a single answer. So this becomes 1 over 49. That is a rational number. That would be your final thing. There's no operations to do at that point. 10 thirds to the negative 3. If you use your exponent rules, the negative 3 would go to the 10 and to the 3. Now you have negative exponents, so that is the same as 3 cubed on top, 10 cubed on the bottom. 3 cubed is 27, 10 cubed, 1,000. Yes? Well, that is part of what we saw in our original pattern way back at the beginning, which was on this page, right? If we kept dividing by 3, 3 to the negative 3, divide by another 3 will be 1 over 27, which is the same as 1 over 3 cubed. So at a certain point, you keep adding, with the negative numbers, you keep adding 3's on the bottom. Some people like to do the negative exponent thing right away. So another way of looking at 10 over 3 to the negative 3 is sort of just doing the negative first. If the negative goes inside as a negative 1, that would just flip that fraction. And then you would still get 3 cubed over 10 cubed, which is 27 over 1,000. Same amount of steps. 1 over 5 to the negative 4 becomes 5 to the positive 4, which is 6. Now for A, this whole thing was over 1 right now, right? And so the negative exponent is in the numerator. It moves to the denominator. This 5 to the 4 here I can make over 1. My negative exponent was in the denominator. Now it's in the numerator. Yeah. All right, how did you do? Okay. I will wait a little bit longer. Some important algebraic observations. First, a very important algebraic observation is with a negative fraction. Negative 3 over 2 is the same as negative 3 all over 2. It's the same as 3 over negative 2, but it is not the same as negative 3 over negative 2. If you have a fraction that's negative, you can put that negative out in front of the fraction like we have here, or you can put that negative with the number on the top, or you can put that negative with the number on the bottom. You can't put the negative with both of them because a negative divided by a negative is positive. Now in this question, when I'm going to distribute the negative 4, that negative 4 has to go to everything inside. So it's going to hit the negative as well. I'm going to choose to put that negative with the 3 so that I would have this. That way the negative still gets the negative 4. Then you would flip them, and so I would get 2 to the 4 on top and negative 3 to the 4 on the bottom. Now when I do 2 times 2 times 2 times 2, I get 16. And when I do 3 times 3 times 3, negative 3 times negative 3 times negative 3 times negative 3, it's going to be positive 81 because there's 4 negatives. Because we're using the negative exponent rule. The negative exponent rule says if you have a negative exponent in the numerator, you write the reciprocal in the denominator with the positive exponent. And here I have 2 to the negative 4. It becomes 2 to the positive 4 when it gets flipped up. Okay? Of course, this one, You could have also done it this way. Flip the fraction and made the 4. Again, the negative and the 2 would go to the positive 4. The 3 would go to the positive 4. You still get 16 over 81. Some people think of that negative in the front as a negative 1 times. Does that make sense? That if the negative's in front, you can think of it as negative 1 times 2/3. But then that negative 1 would get the power of 4 as well, making it positive that way. Okay, E. 16 to the negative 5/4 is the same as 1 over 16 to the 5/4. How do we do 16 to the 5/4? You could do 16 to the 1/4 5 times. And 16 to the 1/4 is the same as the 4th root of 16. Right? That's from the other day.
Can you just translate all of this in like slow person?
Like dumb person, like dumb person here.
Like Matthew speed. That's like
Speak
slower
very
than turtle.
slow and explain everything.
All right, here's the 5.
What the heck? How do you do that?
Okay. So we are using all of the things we learned in this question. The negative 5 over 4 means that you write it on the bottom with a positive 5 over 4. Okay? 5 over 4 is same as 1/4 to the 5, which is what we did the other day. Whenever we have quarters, those are the same as 4th roots. So if we can write it in a way that we can think of it as a 4th root, we'll be able to figure it out. And 16 happens to be one of those numbers that works out perfectly. 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2. And then you have 2 to the 5, which is 32.
Will we ever have a number that doesn't work out perfectly?
Yeah, and then you can simplify it as a mixed radical. So you have to be able to recognize numbers that work out perfectly and see how to simplify them. Do you want me, I want you to try this one on your own. I'm going to come check. I'm going to do it in one of two ways. One way to do this is put the negative half to both. Then change them to positives. The power of 1/2 is the same as the square root. Square root of 36 is 6. Square root of 25 is 5. Just a show of hands. How many people distributed the negative exponent first? Okay. How many people flipped the fraction first?
What if we did both?
Okay. Couple did that. That's fine as well. This gives you 36 to the half, 25 to the half.
What if we just had me to do the second step of
6 over 5. There is a homework. There it is. This is on video, yeah.